Hello everyone, welcome to Learn Overflow. In this video, we'll discuss another LeetCode problem that is a push dominoes. This is a medium level problem and we'll understand what this question is asking us to say and how we can solve a question like this. Before moving on, if you haven't subscribed to Learn Overflow, make sure to subscribe to Learn Overflow for regular LeetCode videos like this. This is like there are n dominoes and we place the dominoes vertically upright. Okay, so like this, the dominoes are placed. Fine. In the beginning, and we simultaneously push some dominoes to either left or right. And after each second, each domino that is falling to the left pushes the adjacent domino on the left. Similarly, the domino falling to the right pushes the adjacent domino standing on the right. Fine. So that's the normal sense. If a domino is falling to its left, fine, it will push this one as well. So that's the normal sense. If there's a domino there that is falling to the right, that will obviously push this domino on the right as well. So that's how this normal domino questions, like normal domino works with us. Okay, let's say what the question is asking us further. The question says like when a vertical domino has dominoes falling on it from both sides, it stays still due to the balance of the force. So that means if there's a domino like this, okay, and there's a domino that has fallen on it from its left, and there's another domino that has fallen on it from its right. Okay, so if that is the case, then exactly this particular domino, okay, doesn't move anywhere. So that's what it says. Like there's a balance of force. You can understand that from both sides it gives a equal number of force. So that's a balance of force that happens. Fine. Now, this is the case they give. Now further, it says like for the process of question, we will consider the falling domino depends no additional force to falling or already falling domino. Okay, so that's just for easier question. They say it should be only this one force will be applied, not like the other forces, like how many others are over here, how many others are over here that have already fallen. Those forces won't be taken care of. Okay, we'll just consider the falling domino expense no additional force. Okay, now here it will further we will understand that there we are given a string of dominoes. Okay, now this is a string given to us, not an array, not an any other stuff, just a simple string. So what it says, the string of dominoes like can have L, can have R, or can have dot. So L means it should be pushed like it is pushed to its left. So that's a L case, that's a R case. Fine. And this single part that is standing still, that is not pushed anyway. Fine. So that is represented with a dot. So that's what it is said to us. And we need to return a string representing a final state. I mean, after a left push is done, after all the right pushes are done, and after all the equal number pushes or whatever is there, all the pushes are done, we need to return the final state, like what it exactly means. Say, so there was one domino which was initially as a dot, and on its right we find a domino that is given a left. Okay, so if that is the case, if there is a left, so left will push this, and this will obviously fall, right? So the final state will be something like left, left. Like this was pushed to left, and obviously this event fall into left. Okay, say after this left, there is another domino that is there with a dot initially. Fine. Then there's another domino that's with an R over here that is it should be pushed right, and there's we consider another domino that is pushed that's right, that is dot initially. So this right will be pushed to its right, and with its force, this one particular will also be pushed to its right. Right. So the final state will be this one goes for right and this one also goes for right. So this is the understanding. But what happens to the middle one, which was initially dot? So this one doesn't exert any force from any side, right? It doesn't get any force. So that's why it remains as it is. So I hope this is understandable, like how what the question is asking us to do, what is the initial state and what is the final state and how we should return it. Okay. Similarly, if I just look at the example one, it says right, right. Okay. And then there's a dot and then it says left. Fine. Look carefully. So there's a right and there's a right. So this right will force on it. And this right will again force to the middle one that is standing still. Fine. And this left will be forcing you to its left. Fine. So after that, there's a right force and there's a left force, and which two neutralizes each other, and thus it remains as it is. So in the final answer, you see right dot left, that remains. But you may question like okay, there's like two right are pushing towards like there are two dominoes that are pushing right, and there is only one domino that is pushing left. So isn't it be like the forces are more? Okay, no, that will not the case. We will not consider because for this they like explicitly said us like for the purpose of this question we'll consider that a domino like falling domino expends no additional force. That means this additional force over here, whatever additional force is there, we'll not consider them. We'll consider only one. Okay, that or already falling domino. Okay, this falling domino is currently this one that is falling to this the third domino, but the already falling domino is this one, right? The first one. So we'll not consider other forces. We'll consider only the falling down. Okay, like that's what it's like. Question is asking us. Okay, so that should be clear for us. Now, if we just quickly look at another example, then we'll look into how we should like solve this. Okay, fine. See, and then the next example, it clearly says something like it shows us pictographically. Okay, what happens? So see, like this dot. So initially it is dot, then there's a left, then there's a dot, then there's a right. Fine. Then there's a three dot, and then left, right, two dots, left, then two dots. Fine. So that was the initially given. So what the output? See, once a left is there, left falls all the like all of them. Then there's a dot which stands as it is because the next one is right. Okay. So right goes and falls the next right, and then look here, the dot remains as it is because on the left also there's a falling domino out there. Fine. And then you can see the left and right, right is going like two steps are there and two steps over here. So that's how it's going. I hope it's understandable with this example. Fine. Now the question is, how should we solve this? Firstly, we are given a string, right? So if we're given a string, so in that case, what we should do? Like we are given a string. So what we can do actually is we can like either convert it to a character array or may go ahead with some other stuff. I mean, a string builder or something. But I think over here, since we need to look for each of the characters, right? What the exact characters are there, okay? Depending on that, we need to make some decisions. So it's better to go convert it to go into a character array. So that's what we'll go with. Fine. Now let's understand what will be our approach. So there can be two, three cases. Okay. So we'll go on with some pointers. Okay. What kind of pointers? So we will find what are the cases we are finding over here? Like there's a start pointer, there's an end pointer. So say we are at this position, fine. So there's a start pointer over here and there's an end pointer over here, fine. So let's consider this example. So from start pointer to end pointer, if we find that in the both cases, like one start is on the right and end is on the left. So that means we should like each one of them, we should keep tracking to the left and right. Okay. Like one start is on the right, so we consider this as right, and then move the next to the right. Then like at the same time move this to the left, fine. And then once we find the start and end are at the same position, so we will be not moving anyone or any side. Okay. Similarly, if we find that first we find an end like on a left array, or like there's a start is something over here that's outside our array, and our end we find a left push, so we push all of them to the left. Okay. Like till the beginning. Similarly, if we find something like say there's a right given to over here, fine. If we find something like that, and we find that's like the end is somewhere outside, like it's is going above, so we will push all of them to the right. Okay, so that are the conditions we will do. Since if we find like this kind of cases where start is there is as a right and end is there as a left, fine. So in that case, we will move both in the both sides. Okay, if we find only the end is there as a left but start is outside, so we'll push all of them to the left. And if we find the end is as right and the start is at kind of like the right is there and end is outside or given a length, so that in that case all of them will be pushed to the right. Okay, see, you may question why we are considering start as always right and like the end as always left. Okay, so why are you considering this? If we do the reverse one, say the start is left. Okay, in the starting, if we're seeing the left, and in the end, we are taking as right. So let's consider if we are considering this. So if we're considering this, see, so in that case, what will happen? If I just show you, say consider at this position. Okay, at this position, if I just try to take it like the start is over here, fine, and the end is over here. Anyway, is any of this like any of these two affect each other? No. Like if this is the condition, start is going on the other direction, the end is going on the other direction, we are not bothered with what we are supposed to do over here, right? Because these two are not interrelated. Is it understanding? Like for the if it is start is going on the left, so start is going on the left, so how much left you should check for? Not sure. Like if the end is going on the right, how much right you should check for? We're not sure. Fine. So that's why like we need to check for those elements which are falling into each other. Okay. If we know that start is not at right, so that this is not the case, so we can find this kind of a solution. But if we find the start is over here, that is start is on the left. Okay. So how much we will keep checking for? We will like there's no point how much we should go this side. We cannot go this side. Like we should go this side. The end is somewhere also like not known to us. Like what is the stopping area? So that's why see this is the like a fall we should visualize, right? The fall is not on the different way. So we should visualize what is the, like, if there's a start fall is going this side, there should be end fall coming back, right? Else everyone will be falling to one side, right? So that's why we are just checking kind of like this. Now there are like 2-3 cases, as I said, if the start is right and the end is left. So we will keep an while loop. I will like keep incrementing our start and keep decrementing our end, and with that we will find out till the points our start and end are becomes equal, right? If they become so. Okay, so that's the case we will do, and we'll keep like changing our array as it is. Okay, changing our array immediately to find like what changes are going on. Fine. The next one, what we will do, we will go ahead with something like say there's a kind of a condition happens where all of that are like, say there are 5-6 elements, there are 2 dominoes, and all of this are dot. Fine, all of this are dot. So if all of this are dot, and then we find and write, okay, then we find and write. So are we bothered about any of this? No. To find a right is gone. If it's the left, then we need to traverse back to each one of them till we find some kind of reverse force to just neutralize our force we have over here, right? So that's the condition we have. Now I hope it's like understandable what kind of approach we are going to do. We are simply going to traverse through the length of the dominoes, like through the character array once, and in that traversal we'll took 2 pointers, start and end, and initially like ultimately try to figure out which side we need to move the dominoes, and ultimately we will make changes for that. Fine. So that's the simple idea. So I think this idea is pretty simple. So let me quickly write down the code for you, and I think it will be helpful for you to understand how this code works or how you can actually find this solution to this question. Fine. So there you say our approach works pretty good, like 84.3%. That's good. So let's understand quickly what our approach, like how we are solving this approach. Okay. First of all, as I said, we have converted our dominoes to a character array. Fine. And there we got a start and the end. So start and end initially we are considering at this dot. Dot means that this conditions. Okay. Now, and we took few other like variables. It is like the start index, the index from which you should start, and the I being the current index. Fine. So what we're doing, we're just going through a one while loop, and this one while loop will be our final answer. Okay. So this is the one while loop we're going through. Now, in this while loop, we got I less than n. So like while we're checking, I is less than n being the length of a dominoes. Dominoes length is actually is equal to a character's length of a character array length. So we just traverse the whole character array, and now we're trying to find out like the start index. Initially we're considering start index with the I. Fine. Our current start. Now, what the few conditions we just put in? We actually like the whole conditioning is done over here, but there are few things we should look forward. Number one, like if we find somewhere like I is less than n, that is I is within our range, and our character array of I, like current I index is dot. Okay, so if it is a dot, if we do we need to do anything? No, we just simply overlook that, and we should only be bothered about the left or the like the last and the end. I mean, if you find a left or you find a right, so that's what we should be bothered about. Now, that's the thing we are doing initially. Now, then what we did, say after all this traversal, in case we find that I is less than n still, so what's the end? End currently is s of I. Fine, that is our current index. That is what it means. It means that this is actually not a dot. Like all the dots are there. That's what got covered. So if you just look at this particular example, fine. Or the first there's a dot, it's got covered. We're not bothered with it. Fine. Then we found L. So that L becomes our first element that is being put as an end. So this is why the end is getting updated from a dot to this end. Fine. This is our end we found. Now we should be looking for what? We found our end. Now we should be looking for whether it's a left or it's a right. If it's a left, we should go traverse back and find a solution. If it's a right, we should find next L. Okay, we should keep traversing to find the next L. So that should be our idea. Now, what happened? Like we got our then we got we're going to checking if our I minus start index. Like if start index is something behind I and I is somewhere ahead of start index. Okay, so else initially, as you know, this is like equal. Okay, so if this kind of statements didn't work, or if either the first element itself is in left or right, so this will work on. So in that case, we find the start index is not is equal to I. So in that case, it will end up having 0. Fine. If I minus start index is greater than 0, that means we got some elements in between them. Fine. Now we got 3 cases. First one is if the start is right and the end is left. Fine. Next, we got if the end is left, which is a case over here. Fine. And then if we find if the start is right, that should be a case over on the right side. Okay, on the right side we don't have any example like that, but that should be a case on the right side. Okay, so one case will be like this: we got the start and we got the end, so that's a traversal through it. Fine. One case will be the end we have left, but the start is not right. Fine, the start is not right. That means exactly what means like when can we get this condition? This condition can only be executed at the beginning on at this position. Fine, as this condition won't be there. Only this places will be traversed again and again. Like start is right, end is left. This should go on again and again and again. But if we have the end, but we don't have a start, that means start is there standing at start like this this initial value. Okay, if you look carefully in the initial run, in this much of code, we haven't initialized changed our value of start till now. Fine, start is initialized the change at the end. Fine, at the last of our code, the start value is changed. So this is a case only when our start has a dot and our and we don't have we have only the end as left. Fine. So then this case will be initialized. Then the other case we have is the start is at right. So we got a start as right. We don't have any example like that to show you to this, but let's understand the start. There's a right element. It should move on the right. That's a start. We don't have an end. Okay. We don't have we got a start as right, but we don't have an end as left. That means it's towards the end of our dominoes array. Okay, so all the elements after that should move to the right. So that's what we're doing. If we are having both like this, the start is right, end is left, we are traversing through it. Okay, and for each of the position, we are making start as right, end as left, and then moving our left pointer forward and right pointer backward. So that's what we're doing. So exactly over here, if you see in the example 2. Over here is the start, here is our end. Fine. We just marked both of them as right and both of this as right and this as left, and then moved our pointer to the next one. Right. Decremented our right pointer, incremented our for start pointer. Right. Then we marked this as right. Fine. And this as left. Right, and then incremented our decremented our left pointer. Decremented our right pointer and incremented our left pointer. Then we find both are at equal, so we don't do anything. So see in this case, what you can actually see while left less than right. I mean, there's no case when left is equal to right. If there is any case like left is equal to right is holding over there, it should stay as it is. It should stay as it is. I mean, it should be. I should consider itself as a dot itself. That will happen. Fine. If there's no element as in between them, no problem with that. We are not bothered with it. So left equal to right is not a case we should be checking forward. Now, the next thing we should look is when the end is left, but there's no start. Fine. So in that case, what you got? We got this from the left index till our start index. Start index so initially as I. So that is if you initially look, start index initially 0. So that's what I will be first case. Fine. So in that, if the left is in the right is left. So what we'll do, we'll consider our left index to be something I-1 and then traverse till the left index, like the start index. And then all of the values on is left over here, we got it as left. So we will start from here till the end, right? Till the end in the beginning. So we'll consider all of them as left. We'll traverse how many elements maybe are there. So we'll make them all as left and then decrement our left pointer. So we are just decrementing our left pointer like this way. So this is where we are going forward. Further, if we have a start as right, that's the, as they say, if we have a start as over here and this is right given to us, fine, this is right given to us. Now in that case, what we are doing, we are considering right is less than I, because right will end up having over here. Fine, if right is less than I, so then we're considering all the values, we're changing all of them, how many are there, we're changing all of them as right and then incrementing our right pointer. So that's what we are doing. And further, if we just see, okay, if we just see further, Look, if I just say further, after this whole traversal stuff are done, then we need to like, if once this whole conditioning, what we say, once this whole conditioning, I mean, this traversal is done, we need to look for the next traversal, right? So what we're doing, we are making a start as the end. Whatever is the end position over here, end position over here was something, what did you see? End version was our S of I, right? We always traverse like S of I. So this will be made a start initially. And then we made I plus plus. So I became over here. And then we got our end as dot. So we marked our end as our dot. Fine. So this is the conditioning we get. And now, so now we are ready to go for the next cohort of all the elements. Fine. So this is the idea. This is the exact idea behind this question. And I hope I can make you understand how you can solve this question. So if you have any doubts still left with you, make sure to comment them down in the comments as well. I'll be happy to help you out with the comments, like help you out in the comment. And also subscribe to this channel for regular LeetCode videos like this. So thank you all for watching this video. Hope to see you soon in my next video as well. Thank you.